I'm going to go over the exercise that we did in the first Ecopath with EcoSim Fish and Fisheries session that we did recently. So I'll open up Ecopath. So this is the most recent model, this is 6.4.3, and then we want to create a new model. So I'll go File, New Model, and I need to save it as something. I'll save over an old one I've done here, so I'll call it Test Model. Save, yes. Yes. Okay, so then we go to Input Data, and the first box we click on is Model Parameters. Now this is just like a basic setup for the model, setting the model up really. And you've got boxes that you can fill in, like a description. You can put the author name in. You can put your contact details in. You can vary things like the year, the location. You can change things like digits. An important part here though is the units that are used for the model. Now you see at the moment it's on wet weights in tons per kilometre squared. Now that means that the model is directly comparable. If you needed to take some data from another model to help with your one, then you would be able to use it as long as that model is written in wet weight in tons per kilometre squared. If it's in any of these other units here, you need to find some sort of conversion factor. I guess that's pretty much the important bit there. If you can't see all of this on your screen, on your computer, if you click on this, it goes down to the bottom part of the screen. There's lots of stuff on here that we're not going to use at the moment. Then we go to Basic Inputs, and you can see here along the top we've got a variety of variables. We've got group name, habitat area fraction, biomass in the habitat area, production over biomass, consumption over biomass, ecotrophic efficiency, other mortality, production over consumption, unassimilated consumption, and detritus import in tons per kilometre per year. But we only have one group at the moment, and that is detritus. So we need to do this exercise, we need some more groups. So we'll go to Define Groups, and we need to insert some groups. So insert, 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 insert. Now you can see we've got 5 groups, which is what we need for the exercise. Now detritus, I habitually make that brown. Right, so but we can now name the groups. We can stretch the columns here. Okay, so we'll start with the highest predator at the top of the list and work our way down. So the top predator in our group is reef piscivores, and then we have reef planktivores, then zooplankton. The names are just labels, so you can call things whatever you want. So, I mean, these are very general. So reef planktivores would be a functional group that includes several species of fish. Reef piscivores is the same. So depending on what you were trying to model, as we discussed in class, you've got to set your model up for what the question you're trying to ask. Anyway, we've got boxes to tick down here. So here we've got detritus is ticked as a detritus class, phytoplankton as a producer. It should be ticked as a producer rather than a consumer. The rest are all consumers. The rest of this we can leave just now. We talked about stanzas as well. So if I had a lot of detail on a particular species of fish and it was something I was interested in from a model, say cod, and I had 5 age classes, I could have 5 stanzas, and I could insert them here. We won't do that today. Okay, so that's all set up now. I can change the colours here again for one, but I'll just leave it as they are. Okay. Right, now we have these boxes. So we can put the input in here, and if we go to the data we've been given for the model, we can fill these boxes in. So biomass is 0.5, then 1, then 2, then 5, then 10. And then we have P over B, which is production over biomass, and the values we've given for that are 1, 1, 10, 100. And then we have production over consumption. So that's not consumption over biomass, it's production over consumption. So we need to put that in. So 0.25, 0.2, 0.2. Okay. Then so we've set this up now. Now we need to fill in the diet composition box. So this column is, I think of it as a larder. So this is a larder for reef piscivores. Okay, so this is what do reef piscivores eat, what proportion of their diet consists of these particular options. The grey box would represent current cannibalism. Okay, so this is where reef piscivores eat reef piscivores. That, of course, that happens in the marine world, but it can be problematic in models. So we'll keep it simple. So reef piscivores eat all of the reef planktivores. Reef planktivores eat all of the zooplankton, and zooplankton eat phytoplankton. Okay, so I put them in like this. I'd like to include just a little bit of detritus in this diet, so I'm going to put 0.1 in here. You'll notice then that this sum, the proportion, goes to above 1, and so we've got a negative value here. We don't want that. We want these all to be 0. We want the sum to always add up to 1. In a very simple model like this, you could look at this and you say, well, obviously this should be 0.9. So we have a total to 1. But in a large, complicated model where you've been messing around with proportions and that you've got slightly over or slightly under, and you just need to do something to get your model to balance, to get your diets to balance and to come to 1, you can use this sum diets to 1 button here, and that will you'll take the proportions here and make them add up to 1. Okay, so that's our diet composition. Then we have another box which is detritus fate. You can decide what happens to detritus. Does it stay within the system or does it get exported? Again, that has to sum to 1. These are proportions. Other production, so you might have stuff coming from outside. So you've got immigration and emigration of different species, and you can have tons or rates per year, or biomass accumulation, tons per kilometre per year. Now we also have to set up a fishery. So we need to define the fleet first. So define fleets. So we've got fleet 1. I'm going to call it the piscivore fleet. Okay. Landings, we're given a value of 0.3 tons per kilometre square per year. We're not given any, so we've got landings. We can look at discards. We're not given any instructions for discards. We could play around with that. So that would be how much is discarded from each of these fleets. We could look at discard mortality rate. We could vary that. We're assuming 100% mortality in discards here, and then discard fate. I think you can set up another detritus group, which is discards from fish. That's recommended practice. We won't bother about price here. Have a look at tools. Now this is an important box here. It's especially important when you're developing your model, because what you need to know is how reliable are the data that you are putting into your model, and they're going to have a variation of reliability. So if you click on Pedigree and then click OK, it gives you this this box here. You've got a range of options here, so you could, let's just move this over here a bit. So you see that each of the parameters for this particular group, so this is biomass and habitat area, which is one of the things we've just put in. For each of the species or functional groups that we've used, we could tell the model how reliable each of those data are. So say for instance that my reef piscivores come from high definition sampling. I can put that in there, and say for reef, that's the same for planktivores. For zooplankton, maybe I've used an indirect method. For phytoplankton, maybe I've made a guesstimate, just made a sensible guess. Maybe for detritus, I'm going to use an estimation from Ecopath. Okay. We could do this for all of these variables here. So we can say, say we've got production of biomass. That's actually quite a straightforward thing to estimate. If you know growth rates and you know biomass, you could do something with that. So we could say empirical relationship there. Okay. So for, let's try the next one, consumption of biomass. I think that would have to be a guesstimate. You see these have changed with each one, so there's standard ways, standard levels of certainty for each of these different variables. Then when we click on diet, there are no classifications there. So for diet, we need to come up with some definitions. So for diet, we'll have three. Let's think, how could we do that? We could do stomach analysis, and we give that an index value. Let's give that an index value of, let's say, so that'd be stomach analysis from a particular place, for a particular setting, for a particular model. That's okay. So if we do another one, we can have literature. That's a little bit less certain, but it's still pretty good. And then we have another one, which would be, let's say, guesstimate. And that would be the least certain of all. So what we do with that, we'll give that an index value of 1. Okay, so we've created our own indexes here. So click OK now. So we want to save that, yes. Now if we go back to Pedigree, yes, and we go OK. Now when I click on diet, it gives me the three classifications that I had in there. So say for reef piscivores we'd done stomach analysis, for planktivores we'd used literature, and for zooplankton we'd done a guess, okay? Because we're only doing a functional group there anyway. And then we have catch. There's nothing in there either. Now I could go and I could put something in there for these, but we'll leave that just now. Okay, well, no, we might as well do it. So we'll define that pedigree as well. Go to catch, and we'll insert one, an estimate type 1, and we'll call it landings data. Oops. Landings data. Insert another one, and let's have a guesstimate there. Okay, so this one, we'll give it a decent level of certainty, and we'll give this one a low level of certainty. Okay, yes. We'll go back to the pedigree, we'll go to catch, and we'll say we've used landings data there. Right. Now, when we go back to basic input, you can see that for all of these things here, we've got bars next to the values. Okay, now that helps us later on when we want to try and balance the model. So now, if we click on basic estimates, this is where Ecopath takes all the values that we've put in and tries and works out what the how they all relate to each other. So it works out the things that we don't have. Like, so we don't have values for consumption to biomass. What Ecopath will do is work out what that consumption to biomass ratio must be given these figures. And it will also work out ecotrophic efficiency. Now, if you see here, we're getting an error model. It's saying your model is not mass balanced. Computed ecotrophic efficiencies are invalid for one or more groups. Computed ecotrophic efficiency value 2 invalid for group reef planktivores. If there's lots of errors, you'll get a whole list of these, and sometimes it's worth making note of those. Now you could do a screen snip and save that as a picture. So you could go, just do a here we go, snipping tool. So I could do a snip like that, and save that somewhere, and I'd have that data. You may not need it. Okay, so when I've clicked OK, you can see that everything's blue, which is good, except for this value here, which is in red, which is the ecotrophic efficiency of reef planktivores. This has a value of 2. Now, if you remember, ecotrophic efficiency is the amount of that particular functional group or species that is being consumed within the food by the food web, by all the predators around. And so it's affected by how much of the animal there is, how much of it's being eaten, what the productivity to biomass ratio is of that particular species. So for phytoplankton, with a biomass of 5 and a fairly high production to biomass ratio of 100, only about 20%, 0.182 as a proportion of that animal is being consumed. However, when we look at the reef planktivores, the value of 2 suggests that twice as much of that animal as there is in the ecosystem is being consumed. Now that's not possible, so we have to think what's wrong with our data at that point. There's something wrong with the model. So we need to go back to the basic input here, remembering what the problem was. Now the problem, well, we'll flick back there again. So the problem is that there's not enough of this species to go around. So that's why this value is high. So there are a few things we can do to change that. We can, if we were uncertain about the biomass estimate, we could increase the biomass. If we were uncertain about the production to biomass estimate, we could increase that. If we thought there was something wrong with the food web, we'd mistakenly assumed that reef planktivores only zooplankton when actually they might eat phytoplankton as well. We could go and change that. I'm going to make a simple assumption that either biomass or production to biomass is wrong. So if I go back to basic input, this is where these bars become useful. So these bars are related to the index we put in as part of the pedigree. So we've got 4 bars next to biomass for both reef piscivores and reef planktivores. So that suggests these are dead certain. We're slightly less certain about production to biomass ratios. Okay, it's still not bad. It's 3 bars. I can't remember what that was, but it's 3 bars. So that's one that perhaps we should change before we change biomass. So if you remember, there was a value of 2 for ecotrophic efficiency, and what we need to do is have more reef planktivores around, or we could have less reef piscivores. I'm going to go for more productivity from reef planktivores. I'm going to double that, okay, and then we'll see what happens. So now when we click on basic estimates, you'll see that that value is 1. That means that all of the reef planktivore production is being consumed by the reef piscivores. I wouldn't be particularly happy with a value of 1. It's a bit high. It suggests that nothing is escaping the attention of the reef piscivores. So I'd probably be looking to see whether I could change that a bit more. I'll leave it just now. If you look at the reef piscivores, you can see that the value is 0.6. How can that be? Because nothing eats reef piscivores, does it? But they're fished for. So this value here represents the amount of the reef piscivores which are being taken by fishing. Okay. So if we fished for reef planktivores as well, we'd find that this value here would probably go above 0.1. Well, we can do that. Let's have a look. So if we go to landings and we start landing a bit of reef planktivore, no, 0.1. Let's say it's bycatch. Okay. So we'll try that. And then we try basic estimates. You see, we've got an ecotrophic efficiency of 1.05 for reef planktivores. So that's basically saying, as soon as you introduce a fishery, this ecosystem would collapse. Right, because you'd have to have more reef planktivores around to support both the reef piscivores and the fishery. Okay, so go back to the landings, get rid of that again. Hopefully you can see how you can play around with this and sort of right. You can play with that a little bit. Right, there's other stuff we can do as well, but I'll leave it just now. The only other thing I want to show you is that you can also produce a flow diagram. Now this is useful in reports as much as anything else. So you can have this here, where you've got, so this shows you the sort of flows between functional groups. We've got phytoplankton, zooplankton, reef planktivores, and reef piscivores all here. So we can change this a bit. So we can change the colour. So there's a variety of different ways you can do the colours. I don't know what they all do, but you can change them according to. So I guess these lines indicate degrees of flow. So these are all 1s, and this is a low value here. You can also have the. You can also scale the lines. So you can see these are thick lines because all of that's being consumed, whereas not much of that's being consumed. You can also move this around a bit. So you can move your. When you've got a complex food web and you're trying to show a particular thing, it's quite handy to be able to do that. You can move the titles separately so you can see them. So I'd expect to see one of these in your report, maybe with some annotation showing key points that you might that might be of interest. Okay, well you can see the index up here from 0 to 1 here, which is an indication. So these indicate the flows between nodes. So this is a node. This is a connection here, or an arc it's called sometimes when we're looking at networks. Here you can see the trophic levels. There's trophic level 1 phytoplankton, trophic level 2 zooplankton, 3 reef planktivores, and 4 reef piscivores.